Hello. In this video, we are going to study a new type of measures. Um it is a measure of asymmetry. So let me review what we have done. So if you need to summarize data into one number, it is the mean or a measure of central location. If you use two numbers, it is the mean and the standard deviation, or the mean, a measure of central location and a measure of variability. Now, suppose that if you can afford a third measure, then what is that? The third measure is a measure of asymmetry, or you may also mathematically, the mean is of the first order. You don't square or anything. It's just x itself. And the second measure is the variance or standard deviation. And basically it's about the squared deviations. So you are taking square. And the third measure is about asymmetry. And you are going to use a polynomial of 3, exponent of 3, which is cubed deviations, which means deviation is multiplied 3 times. So it's a cubic deviation, not square. And take the mean of these guys. Remember, the variance is the average of square deviations. And now the third order is the average of cubed deviations. That is called the skewness. Skewness is a name for this measure. And skewness is defined in this. I'm not going to go deeper. Just to tell, the idea is the same and calculation is the same. You don't need to know how to calculate this. Just I give you the basic ideas. So if you calculate the mean of these cubed deviations, it will be 0 if the distribution is symmetric. If the distribution is symmetric, the third order measure will be 0. But if it's positive, that means there are outliers on the larger side. There are super rich, like giants, like super extremely large values are included in your data. But if the skewness is negative, that means the outliers are on the smaller side, which means some observations are exceptionally smaller than the others. So graphically, this is what I'm saying. If you have, like, in this case, in this picture on the left, the tail is long on the left side. It goes far on the left side. So, but on the right, it drops quickly, and that's it. And we say, in this case, we say the distribution is left skewed. It's asymmetric, and particularly it's going far on the left. So these outliers are very small values. Extremely small values lie on this side. So it's left skewed or negatively skewed. It says going down. Some observations are being very small and long left tail. Or interestingly, you can connect this measure, this shape, to the difference between mean and median. In this case, small outliers are the mean is more sensitive to these outliers. So the mean will decrease much more than the median by these outliers. So the mean must be smaller than the median. So in some textbooks, the difference between the difference between the mean and the median is also introduced as a measure of asymmetry. But I don't know. I like that makes sense, but more more dominant measure is the skewness, the third order measure. Its its counterpart is the right skewed distribution. It has outliers on this side. Exactly, it's a mirror image. So there, the small side, Small observations do not exist, but there are outliers on the larger side which have extremely large values. So we say this distribution is right skewed or positively skewed, or it has a long right tail. And as we learned, the mean is greater than the median in this type of case. And many economic data have this kind of shape, like super rich, or like Amazon, Apple, Microsoft are here, or you may have this type of data in finance, like say when the stock increases, it increases by say 1%, 2%, but when it drops like 20%. So when it drops super, but when it increases slowly, then drops. Increase slowly, then drops. So that's an example of left skewed distribution. And like super rich is an example of right skewed distribution. Okay, this is a measure of asymmetry, and it's about the shape of the distribution. And typically, when you have uh, it's a third dimension of the third aspect of shape of the distribution. And now, let me stop this video here. Chapter 4 was a little bit short, but I think it's not a problem. It was short. 3 was a little bit longer. Okay, then see you in the next video. The next video will be the last video in this chapter. So I'm going to talk about a different topic. So I will split the videos at this point. Thank you.